Welcome to all. This is part 6, most probably part 6. You can see in the thumbnail. Finding, I written here once again, calculation of ultimate MR for a doubly reinforced rectangular section by limit state method. Why I wrote heading once again? Because now question number 2, most important, because we are using now onwards TORSTEEL. Both practically and also examination point of view, either academic or competitive examination, anyone, important. Because nowadays, neither practically, first of all, mild steel is not used. But examinations, either competitive or academic, rarely they give mild steel. Mild steel means you are happy because number of cycle, usually only first cycle you get the answer. Rarely second cycle. Difficulty comes for TORSTEEL. You will be knowing little later. See, minimum 3 questions. A, this question, it will come very fast answer. Repetition will come immediately. B, it will come after around 2 cycles. But C, I will set a question where repetition will come, that is in trial and error procedure, after 4-5 cycles. So if you study all these 3 thoroughly, you will have no difficulty for finding ultimate MR of WI per section. Now note, IITWOIDOLP. You guess what is that one. I will let you know little later. Little somewhat inspirational. What I will tell little later, not now. Soon I am uploading a class. A class means information class for my future courses. There I will fully explain what is one. Wait for some time. Till that time, think about it. Okay, start. Now, question 2A dictated in class. As I told earlier, my speed, I am in the process of or transition period of the way I talk. Earlier, I used to talk little fast, I told. Slowly I am reducing, but still sometimes old natural habit, it comes. So now I will seriously try to tell slowly now onwards. In case you feel this is too slow, you let me know in the comments. But not very slow like a beam, not that way. But important is what I tell should be audible to you. You should understand. That is the most important. And remember, TORSTEEL is the most important. And as I told earlier, many places or majority of the places, they make mistakes. So therefore, you can be sure, 100% sure that what procedure I am giving is fully correct, 100% correct. People who know me, they know about it. Okay, start. Question 2, first I will dictate. See, once again I wrote everything this question. The cross section of a beam has width of 300 millimeter and overall depth of 450 millimeter. The beam is reinforced on tension side by 4 bars of 25 mm diameter at effective cover of 60 millimeter, and on compression side by 3 bars of 16 mm diameter at effective cover of 50 millimeter. Taking M20 concrete and TORSTEEL of grade FE415, find ultimate MR of the given cross section. Okay, start. Solution. First, write solution for question 2A, given cross section. Bending is not given, sagging, hogging. Whatever you take, same answer. Sagging means from top compression. So your D dash XUD will be from top. This will be ASC, this will be AST. I'll write here. This will be your ASC, this will be your AST. By chance, it is a hogging BM. No, you put no means not wrong. Not this sketch. This will go there, top. That will come to the bottom. The 60 will go to top. 50 will come to bottom. D is from here. Once again, same answer. So it hardly matters. See, for example, I will see this is sagging. Someone who is looking from this way, he will tell it is hogging. So same, he will look this way and tell it is hogging. But whatever is there, see, whether I tell looking this way, sagging. Someone look from top, he will look this way and tell hogging. For both of them, both of us, tension here, compression here only. That will not change. Okay, now start. Now I will reduce the speed slightly. Breadth B, 300 millimeter. Effective depth D. This all I told, basic data earlier. See procedure sheet, I told get all these values. D, 450 minus 60 directly. Why? Because effective cover given, 390. Area of steel in tension, I need not waste time. Pi by 4, 25 square into 4. Area of steel in compression, pi by 4 of 16 square into 3. Effective cover to compression steel from here to center of the steel, 50 directly given. Now if they give clear cover, add half diameter. Here if they give clear cover, subtract not only 60, also half the diameter. Concrete M20, FCK 20 Newton per mm square. Steel Fe415, Fy415 Newton per mm square. For Fy415, XU max by D is 0.48 as per IS code, required to find ultimate MR of given cross section. Start. First, see this color green is for actual neutral axis. I am telling from beginning. First, location of neutral axis for given cross section. That is, how much is XU? As usual, let XU be the depth of neutral axis from extreme compression edge. You should write it, XU over. Equate resultant compression force to tension force. Cu equal to U. This all I told you. 0.36 FCK is the average stress. BXU is the compression area. FSC is the stress in compression steel. Into ASC is the area compression steel. Total compression equal to 0.87 FYAST, stress into area of tension. Of course, that some people write instead of FSC, FSC minus FCC. But IS code told not required. Actually, correct is not FSC, FSC minus FCC, because when you take area B into XU, this full area considered, but that much area of steel is not there. So minus is correct, but I am not doing it because IS code told clearly you can ignore it. So that nobody tomorrow should tell wrong, he is not using FCC. I will tell them I told in the class. Now where, see once again I wrote FSC, see dotted troublemaker is the stress to be considered, not design stress. Analysis problem, I told FSC is the stress to be considered in steel in compression for given cross section. FSC is to be obtained based on epsilon SC, that is strain in steel in compression. Formula I told. IS code has given XU max here. I told don't use it. It is only for design. You'll be knowing little later. Even I am uploading 2 classes for design part also for your information. So 0.0035 XU minus D dash by XU. Now I will continue, because if I rub as it is here, stains will be left. I want a clean board. Just take batter off. Few seconds for you. Okay. Now, usual statement you have to write. XU depends on FSC, but FSC in turn depends on XU. Why? Unless you know FSC, you can't find XU. Okay, but unless you know XU, you can't find epsilon SC. But FSC you have to calculate based on epsilon SC. You can see here, XU comes here. In FSC also, XU comes here. So XU depends on FSC, which in turn depends on XU. This is already told so many times, but since it's an important class, I am slowly telling it. So I told, therefore, XU is to be calculated by trial and error procedure. Okay, remember trial and error. Okay, now start. First, trial 1. What you do is, see, unless you get XU, unless you get FSC, you cannot find XU. So this FSC, for this equation, you find for XU equal to XU max. Because I told, anyway, XU cannot come more than XU max. Or you can tell not cannot come, it can come. Even if it comes, we cannot consider more than XU max. Finally, what happens? Your XU to be considered is either XU max or lesser. So start from there. If lesser comes, we will take later. We will see what happens now. Start. XU max equal to 0.48 into D equal to 187.2. Substitute XU equal to XU max equal to 187.2, 0.0035 into 187.2 minus 50 by 187.2, you get epsilon SC. Now epsilon SC came. I already calculated. Note, actually in exams all not required, right? Now for this epsilon SC value, calculated value, we have to find FSC. Remember, make a note, now you are changing over to TORSTEEL. I will tell once again briefly. TORSTEEL, you first find, I should not tell, what is the epsilon SC at proportionality limit. Epsilon SC PL. It is 0.80 Fy by 1.15 S. If it is mild steel, 0.8 is not there. Okay. That is from where curvature will start. Calculate it. 0.80 Fy 415 by 1.15 ES will come 0.00144. Now what you have to do? You compare your actual epsilon SC or epsilon SC calculated 0.00257. It is more than epsilon SC at proportional limit. What to do? I told, usually 99.99% it will come more. But I can set a question where it comes lesser. But that section will look very odd actually. Someone will be laughing. Is this a real practical section? So therefore, anyway, I give an example for you. Make a note. By chance, if it comes less, then IS code you refer, but not required. Direct answer, FSC equal to whatever strain you got multiplied by Young's modulus of steel, same as no graphic, no reading from the graph, no referring SP16, nothing. Whatever strain you got multiplied by Young's modulus of steel. But we got more. Now, I will continue. The space problem once again. I will continue now. Dot. Start now. Epsilon SC calculated, we got more. See, this is an old one, don't see this one. See, now, to get FSC using IS code, figure 23A. Remember, I told, can be used for any grade of TORSTEEL. So, but if it is, make a note there, but if TOR of FE415 or 500 is used, you can use SP16, then this struggling is not required. But some examination, especially academic examination, they don't give SP16. So therefore, we will stick to IS code. Okay, later we will see. So IS code means, if you go for this graph, slight error will come. Carefully do it. I told this page, figure 23A, you take a big Xerox. You call some jumbo Xerox like that. Big Xerox. Okay, start. Now, make a note. Whenever the strain comes more than what? Strain at proportionality limit, you are beyond this point. See, this is values are given for Fy curve. I told you, you have to use Fy by 1.15 curve. But all the values are given for Fy curve. So this is, see, cross mark, not to be used. Still use it. Why? Because for this curve, values are not given. So no problem. I told very clearly earlier. Use this curve, but whatever you get stress here, I told already, this is the stress, this is the strain. How many times I told? Strain means what? Epsilon SC. Next time I won't tell. Stress means FSC here. But whatever you get, never forget to divide by 1.15. Start. 0.00, how much? Our strain is, see, you can make here, just make a note here, epsilon SC, or I'll write it down, see. Therefore, I'll write here, therefore, from IS code, solution now, see, after the graph, from IS code, using figure number 23A for epsilon SC calculated equal to 0.00257, we get FSC equal to, we get right here for that one, okay, calculated, we get FSC equal to, see here, 0.002, it's getting pulled there, wire problem, okay, 0.002, 0.003, 0.0025, it is 257, almost 26. After center here, slightly move this side. Okay, then don't worry about these lines all. Go vertically up correctly, touch this curve. Actually, this curve you have to use, but you cannot use because values are not there. Use this curve, later divide. Then come this way. I think it is coming, see, 0.95 is there. It is coming somewhere here. Okay, now this value how to decide? See, 0.95, actually it is coming very close. 1 minute, it will come here. 0.95, as per my judgment, 0.95, 0.96, little upper it will come, Anisha. It will come somewhere, Anisha, 0.96. How much I noted the answer? 0.961. Okay, 0.95. See, 0.96, 97, 975, 95. I think if you see here, it comes slightly here. Okay. So, as per my judgment, it is almost equal to 0.96, but slightly more. So, I will take 0.961 times Fy. But remember, I told never and never forget to divide by 1.15 equal to, actually students know, sir, cheating sir, why? Sir, because you already saw SP16, you already calculate what value you should get, and accordingly you are writing. Yes, correct, I am teaching. So little error will do. Okay, equal to 0.961 into 415 divided by 1.15 will come. I already calculated it. Okay, I'll calculate once again here. There's a calculator here. I'll calculate once again, no problem. 0.961 into 415 by 1.15 is 346.8. See, first decimal is sufficient because why? Trial and error. It will come 346.8 Newton per mm square is the answer of FS you get. Now, this is over. Just make a note. I will write now only. Now, I will not go for change of the color. Okay, 1 over. Now, see, I rub this one now. So, we got FS. Okay, now nothing to worry. Right here. Right here. Or, make a note. Since steel used is TOR of grade Fe415, but remember, or even or, we can, or even for Fe500 also, okay. Okay. Ours is 415. We can refer SP16 whenever what? SP16 whenever epsilon SC calculated is more than epsilon SC proportionality limit. Less means they have not given because they also know multiplying modulus. Okay, now, provided what? Provided it is allowed. It is allowed in examination. Allowed in examination. Therefore, practically those who are solving, it is always allowed. But if examination, if allowed, okay, otherwise IS code, okay, then refer to SP16. SP16, table A, page number most probably, page number 6 I think, page 6 most probably. See, they are given strain. Strain means epsilon SC. And here stress. Stress means Fy in Newton per mm square. If you see that IS code table, where is IS code? I have bought it here. I forgot actually. I bought it here. Ah, it's here. Okay, okay. It's a almost damaged ones. Our strain is 0.00257. So for strain, 0.00257 lies between 241 and 0.00276. For 0.00241, see further, for, you can write here, you should refer for Fy equal to 415 Newton per mm square, not 500. 415 it is 324.8 and other one is 342.8 Newton per mm square. Okay, now IS code only told intermediate values go for linear interpolation. Therefore, for our epsilon SC equal to 0.00257, huh? I think 257, yes, 257, we get FSC equal to by linear interpolation. Those who got difficulty can go to playlist of my channel, go for mathematical concepts. There, see class number 3, thoroughly I explained interpolation, linear interpolation. Actually, I already got the answer. I will do it for paper side. See how I interpolate, don't worry. See, 342.8 minus 324.8 divided by 276 minus 241 into 257 minus 241. That much I have to add to 324.8. Something wrong. I can make out 342.8 minus 324.8 divided by bracket 276 minus 241. 0, 0 I am not doing. Into bracket 257 minus 241. That much I would add to 324.8. There is some problem in the calculator. What is happening? 342.8 minus 324.8. Is it correct values? Actually, there is some calculation problem. 0.00241 and 276, correct. Oh, it is not, sorry, it is not 342. It is 0.00241 is 342. See, I can make out here something wrong. This is 342.8. Okay. See, I can make out mistake. This is, see, sometimes it happens. 340, I interchange 342.8 and 351.8. Okay. 351, because I am getting very much different from that answer. I can make out now. Okay. 351.8. Okay. 351.8 minus 342.8 divided by 276 minus 241. Someone will tell, sir, 0.00 is there, you take it, no problem. I don't want it. Into bracket. What is the value? 257 minus 241. That much you add to 342.8. 346.9 Newton per mm square. This answer I am getting from S16. Now make a note. Oh, almost same, because there you got 346.8, we got 346.9. Now, which one to continue? Anyone you can continue, but since SP16 may not be always available, restrict, see, suppose you are using FP550 steel, SP16 not possible to use. So we will do one thing, now onwards, I will continue with IS code so that useful for students. Okay. Therefore, I will take, therefore remember same, but we will continue as per IS code value of 346.8 Newton per mm square. Okay. Now, last step now, almost over. I have to rub and do it. 346.8 confirmation. So I will write here. Confirmed value 346.8. Okay, for my reference. This I will remove now. And close the question so that, okay, now see what to do. This all over now. How you got? This I have not removed because I require it for understanding purpose. 346.8. Okay. Now, so we got trial and error procedure. FSC came. Now see. substituting FSC equal to 346.8 Newton per mm square in expression for neutral axis, and find XU. Okay, start. That is this equation. Substituting 0.36 into FCK 20 into B is 300. I noted down somewhere there. Into XU plus FSC 346.8 subject to verification into ASC 603.19 equal to 0.87 into 415 into AST 1963.5. We get XU equal to, right? We get XU equal to, I noted down already, no waste of time, 231.36 millimeter. Now you are very 231.36 millimeter. Okay, 231.36 millimeter. Now you are good news for you. See, immediately, therefore your XU calculated value of 231.36 millimeter is more than your XU max of 187.2 millimeter. Therefore, cross section is, some outside sound is coming, car siren, cross section is over reinforced. Light time they are disturbing. Cross section is over reinforced. Now, those who want personal note, right here, I should not tell. Less means less, equal means equal, but more means equal. Okay. Therefore, right here, whenever your XU comes more, this value gets cancelled, you have to take equal. But one statement you have to write, I will write last time. Ultimate MR of over reinforced section, I should not write, is considered, is limited to that for a balanced section. That is for your XU equal to XU max. XU max equal to, in our case, 187.2 millimeter. Okay, now see what happens. Okay, now our XU is 187.2. Now see, note, this is trial 1. Therefore, at the end of trial 1, XU confirmed is 187.2 because it came more. And at the starting of trial 1, to get FSC, we assumed XU equal to same 187.2 only, that is equal to XU max. If you remember, it is still there. See, it is still there, equal to XU max. Over. Therefore, you can tell trial and error stops here. That is no more trial. Or now if you continue 187.2, once again same value will come. Therefore, your FSC also equal to whatever you got, equal to same. How much it is? 346.8 Newton per mm square for XU equal to 187.2. Over. Now last step. Over. Everything over. Last step. At right time I am not getting that rubbing part. Somewhere I throw it out sometimes. Then search for it. Again disturbance from sound. Okay. This all I will remove now. Now nothing required. Closing part. This is also not required. Therefore, confirmation. See, today you escaped in one trial. Second question, it may come 2 or 3 trials. Third question, at least 4-5 trials. Confirmation, XU equal to 187.2 millimeter. Night time they are going for this one, and FSC equal to where is FSC? 346.8 Newton per mm squared. Okay, now write. Therefore, ultimate MR MU equal to 0.36 into FCK into B into XU into D minus 0.42 XU plus FSC into ASC into D minus D dash. If you use basic equation, this I am writing every time, if you use basic equation equal to 0.36 into FCK 20, B is 300, XU is 187.2 into 390 minus 0.42 into 187.2. Somebody disturbing from outside, that car siren, plus FSC, okay, I think audible, 346.8 into 603.19 into 390 minus D dash is 50 equal to, you get 10 to the power 6 Newton millimeter, that is kilonewton meter. MR, 197.03. 197.03. 197.03. Or if IS code version is used, then MU equal to 0.36 into, it is in the ratio of XU by D with BD square, XU by D into 1 minus 0.42 into XU by D into BD square into FCK plus FSC into ASC into D minus D dash. Here, what you have to do? Before substituting, you have to find XU by D, but actually not required because for this XU, this is XU max. Okay, calculate if you want. Somebody will be laughing. He is not knowing that. I know it. Divided by 390 will come 0.46. Now substitute here. Or lastly, just to make the perfect conclusion, I substitute now. Therefore, MU equal to 0.36 into 0.48 into 1 minus 0.42 into 0.48. That sound is disturbing me like anything. Into 300 into 390 square into 20 plus 346.8 into 603.19 into 390. Hope it is not disturbing you also. 10 to the power 6 Newton millimeter or kilonewton meter, you write 100% same answer. Over. Okay. Sound is becoming more and more. Okay. It is actually nearing midnight now. You don't know people, they don't take proper care of their vehicles. Someone will touch the vehicle, siren will come. They should come out and do something. They are deeply in sleep, I think, most probably. Okay, no problem. Hope it is not disturbing too much. Okay, now, question 2A over. Easily we escaped here. Next class, I will upload one more question where not, see, first trial came. It came in first trial. First trial it will not come. Some changes will come. Second or third trial, answer will come. Then I will do one master question where at least 4 or 5 trials are required. Then I will go for design part of singly and doubly. Okay. Little later, I will upload for T sections also. Then I will stop this uploading because regular class I will continue there. Design of actual design concept of all arrangements, in the class I will do it. General public, this much information.